Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face Trending List, published on November 26, 2025, just yesterday. It introduces Monet, a way for multimodal large language models to think with continuous visual embeddings instead of explicit images, and it reports consistent gains of about 4 to 10% on tough visual reasoning benchmarks. The paper is titled Monet, Reasoning in Latent Visual Space Beyond Images and Language. And as we will see later, the implications for visual reasoning and reinforcement learning are quite significant. Also, the authors shared an official GitHub repo for Monet. There you'll find the full training and inference code, including modified QN 2.5, -VL and VLLM implementations, SFT and RL training scripts, dataset hooks, RL with external API judges, environment setups, plus a quick example for running Monet 7b with latent reasoning. Figure 1 shows how Monet actually thinks in latent visual space, both during inference and during training. On the left, the pipeline answers a geometry question by inserting a latent token and then rolling out a short sequence of continuous latent embeddings, which act like internal sketches the model consults before resuming text. On the right, the training panels illustrate 3 supervised fine-tuning stages that first warm up the base model, then create high-quality target latent embeddings, and finally teach the model to generate them without extra images. The last panel adds visual latent policy optimization reinforcement learning, so rewards directly shape those latent thoughts instead of only the text. Figure 2 explains how the Monet SFT 125K dataset is carefully filtered so that auxiliary images really matter and stay reliable. The top left panel shows stage 1, where the base model tries questions with the original image and the pipeline keeps only those it answers incorrectly. The middle band depicts stage 2, which validates that added auxiliary images let a stronger model solve the same problems. The right panel shows stage 3, where advanced language model judges marquee visual observation tokens, giving very focused supervision for learning latent visual thoughts. Table 1 summarizes the composition of the Monet SFT 125K dataset. It lists 6 data sources covering chart, real-world, document, and geometry problems. Visual operation types range from drawing bounding boxes and highlighting to cropping and adding auxiliary lines, which capture both simple extraction and more creative sketching. The last column shows that most chains of thought come from visual COT, while smaller but important portions come from focus sets like refocus and zebra COT geometry. Figure 3 spells out how supervised fine-tuning teaches Monet to think with latent visual thoughts rather than raw auxiliary images. The top left panel shows stage 1, which simply warms up the base model on text-image interleaved chains of thought so it stops ignoring auxiliary views. The large right panel shows stage 2, where a teacher with real auxiliary images guides a student that only emits latent embeddings, using controlled attention and alignment loss. The bottom panel then shows stage 3, which trains the model to reproduce those target latent representations even after the auxiliary images are removed. Table 3 shows that Monet 7b, with visual latent policy optimization, clearly outperforms both the base QN 2.5 visual language model and other open-source systems on real-world perception and reasoning benchmarks. The table covers 4 suites: V-Star, HRBench 4K, HRBench 8K, and MME Real-World Light, which span attribute recognition, spatial reasoning, and general perception. Monet 7b reaches about 83% on V-Star and around 68% on HRBench 4K overall, which are several points higher than every open-source baseline. The green relative improvement row highlights gains of roughly 4 to 10 percentage points across these benchmarks, showing that latent visual thoughts plus tailored reinforcement learning make a concrete difference. Table 5 shows that every major component of the training recipe is necessary to reach the strongest visual reasoning performance. The full Monet 7b model scores highest across all 5 benchmarks, which means that visual latent policy optimization, auxiliary images, and observation token alignment all contribute real gains. Removing visual latent policy optimization and adding standard GRPO already drops accuracy several points. Stripping out latent-only backpropagation or the auxiliary images hurts even more, and turning off observation token alignment gives the weakest results, especially on visual puzzles, so focused supervision on those visual tokens clearly matters. Monet shows that giving models internal visual thoughts, these continuous latent embeddings, can substantially boost visual reasoning and even generalize to abstract puzzle-like tasks. The visual latent policy optimization step hints at a broader future where reinforcement learning optimizes not just words, but rich internal representations. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.